Okay, so I told you guys that there would be one little trick with this, and it really is not anything procedural at all. It's just at the very beginning of this. So if we look at this problem up here, we have an x to the fourth plus an x squared minus 90. And you might notice that some things might be missing there. For instance, the important thing that we need to note is that this is missing an x cubed term and an x term. Now, is that important? Okay, well, in our number system, when I was going to divide something, say that I had 10,190. Are those zeros important when I'm trying to do my math? And the answer is yes. Okay, if you tried to multiply this by some number versus taking out the zeros and multiplying that same number times this, would you get a different answer? Yes. So those zeros are there to hold a place. This is holding your tens place. This is holding your thousands place. And those place values are important. Okay? So your place values in our number system are zeros. So we need to have place values for these x cubed and these x terms. So when I write this problem down, I will have an x to the fourth plus, I need to have a 0 there holding the spot for my x cubed. So I'm going to write that in as 0x cubed. Okay? Plus x squared. We have an x squared term. And then again, I need a spot for my x's. So I'm going to do plus 0x minus 90. Okay? So the only reason I showed you guys this one here, one, to get another practice, but also because we are missing terms and we must add placeholders. And our placeholders that we're adding for this problem are 0x cubed and 0x. I've had kids in the past ask if we have to have a 0x to the fifth. Well, if I write down that number 10,109, I do not need a 0 in the ones place. It's just assumed that all of these other places are 0. So once you have your highest power, that x to the fourth, you do not need any other placeholders in there. What are we dividing this by? Well, we are dividing this by x plus 3. Okay? So now our procedure is the exact same. We are going to do what times, and we're only looking at our leading terms, what times x equals x to the fourth. So what's going to go in that box there? What times x equals x to the fourth? Well, that would be my x cubed. I'm going to line up my x cubed, and now I've got to take that x cubed times my entire divisor. So I've got to take x cubed times x, which gives me x to the fourth, and x cubed times 3, which gives me a 3x cubed. And you can now see why we need that placeholder, because we are going to be having cube terms in this problem. Okay? So now we're ready to do the fun part where we all say it together. We're going to draw the line and change the signs. Good job, everybody. Okay? Once we do that, we're just combining our terms. So we will be not having any more x to the fourth terms. 0x cubed and a negative 3x cubed. So I have negative 3x cubed. I'm going to bring everything else down. I probably need to start writing smaller so it'll all fit. Okay? And then again, we just repeat. What times x equals, what's our new leading coefficient? What is a negative 3x cubed? Okay, so what goes in the box? Well, I'm going to need a negative 3. And then I've already got an x, so I need 2 more. So negative 3x squared. Now I've got to take that negative 3x squared times x and that negative 3x squared times 3. So I get a negative 3x cubed. And then negative 3x squared times a positive 3 gives me a negative 9x squared. All together, we're going to draw the line and change the signs. My x cubed terms are gone. And now I have a 1x squared and a 9x squared. So that gives me a 10x squared. Bring it all down. Okay, and repeat. Get rid of all that blue stuff there. What times x gives me 10x squared? Well, I'm going to need a 10, and I'm going to need an x. So that's a positive 10x. Positive 10x times both of these up here gives me a positive 10x squared plus a 30x. All together, draw the line, change the signs. X squared terms are gone. 0 and negative 30x gives me a negative 30x, bringing down the negative 90. Repeat. What times x equals negative 30x? Well, we just simply need a negative 30. Plug in my negative 30. I am going to distribute. So I get a negative 30x minus 90. Draw the line, change the signs. My x's cancel, and my negative 90 and my positive 90 cancel. So I have no remainder. So since I have no remainder, that means that my answer is just simply x cubed minus 3x squared plus 10x minus 30. Okay? So, why are we doing long division? Well, long division is an advanced way to factor. Okay, so it's a way that we can factor more complex polynomials. So why are we doing long division? We can factor more complex polynomials. Okay? And basically the way that we are doing that is this long division is allowing us to check if something is a factor. Okay? So we're doing it because it allows us to factor those more complex ones, and it is doing that by proving if something is a factor. So, say I give you a number like 34. Okay? If I gave you that number like 34, is 6 a factor of 34? Well, how would you tell that? Most of you guys would pull out your calculator and you would take 34 divided by 6. And when you took 34 divided by 6, your calculator would give you, maybe I should pick an easier one, 5.667. That 6 repeats, not the 7 repeats, sorry. Okay? But you would plug that in your calculator and you would see that it had a decimal number and you would say, oh no, 6 is not a factor. And the reason is when you divided it, it had a remainder. So if it has a remainder, it is not a factor. But if you divide it, so say we did 34 and we wanted to know, is 2 a factor? Well, I would take 34 divided by 2, and when I did that, that would give me 17, right? Yep, that would give me 17. There is no remainder on that, so we would say, yes, 2 is a factor of 34. So that's essentially what we're doing with this here. So the first question that this is asking is x plus 2 a factor of x to the 4th plus 5x cubed plus 4x squared minus 9x minus 15? Well, we did that one earlier on the front, okay? And we did our long division. Is it a factor? Well, we have a remainder. So since I have a remainder, I can say that it is not a factor. So x plus 2 is not a factor because it has a remainder. Versus the other one that we did is x plus 3. Is that a factor of x to the 4th plus x squared minus 90? Well, if I look up here, do we have a remainder when we divided these two? And the answer is no, we did not have a remainder. So that means that x plus 3 is a factor. So x plus 3 is a factor because it has no remainder. Okay? So much like when I do something like x squared plus 5x plus 6, and I tell you guys that that factors to an x plus 2 times an x plus 3, okay? Since I know that x plus 3 is a factor, then that means that if I wanted to know what x plus 4 plus x squared minus 90 factored to, well, I know that it would factor to an x plus 3, because we checked that is a factor. And then the other factor that we are dealing with is just the answer. So x cubed minus 3x squared plus 10x minus 30. Okay? So I can say that this factors plus 10, no, that's not it. Oh, that was too hard. I should have wrote it down. Minus 3x squared minus 3x squared plus 10x minus 30. Okay, so I can say that this here would factor to this here. Okay, and then later on in the year, we're actually going to learn how we can factor some of these as well. Okay, but so why are we doing this long division? Well, it's a way to factor the more advanced problems, and that's your reason. Okay, there are two more here on the back. We will work on these in class, but it would be good to go ahead and practice doing these. We will probably not do whiteboard work just because these do take up a lot of room, but we will be working on this next class time.